Hey guys, and welcome back. So we are going to be talking about solving now systems of equations using Cramer's rule. I know, a lot of new terminology for you guys. Again, if you guys have questions on this stuff, please don't hesitate to ask me. I love the matrices unit. It's probably one of my favorite units to teach, just because there are also so many benefits for you guys, again, like I've mentioned so many times before. So really important unit that I'm showing you guys that you'll actually use outside of high school, okay? All right, so I start us off with a little introduction here. So you guys remember seeing systems of equations where there's three of them, okay? And that was actually the very first lesson I did with you guys where we solved a 3x3. So with matrices, we can actually rewrite matrices as follows, where I take all of the coefficients in front of the variables. So all the coefficients in front of the variables gets a matrix. The other matrix is the variables. And then the last matrix is the actual whatever is right of the equal signs, whatever it actually is going to equal. Okay, so just to give an example here, if I were to look at this first row, all of the coefficients are 1 in front of the variables, so hence the 1, 1, 1. We have x, y, z, and it's equal to 1. So that's just dealing with the first row. Okay, so that's just an example for you guys just to see what it's looking like. All right, so a general system of two linear equations with two unknowns, x and y, could be written as follows. Again, take those coefficients out front of the variables. Okay, we got a, b. And we have C and D, okay, here. Again, we're multiplying by the two variables, and we're setting it equal to the constant on the right-hand side. All right, so this is how we're going to be setting up our matrices. So Cramer's rule is actually extremely useful, probably one of my favorite rules for matrices that we're going to be using. All right, so the way that we set up Cramer's rule is as follows. We have A being the coefficient matrix, X being the variable matrix, and the constant matrix being D. Now, I believe if you guys refer to my answer key later, which I'm going to be uploading at some point for you guys all to look at, I believe I actually used capital letter B. It really doesn't matter. In the end, you're still going to get the same result. We're just using variables to make this a little bit simpler. All right, so the way we actually write this out is we have, and if I'll scroll back up, this would be considered my matrix A. This would be considered matrix X, and this would be considered matrix D. All right, so A, again, is the coefficient matrix. We have X as the variable matrix, and the constant matrix is D. All right, so let's actually look at some examples. So, first thing, to solve using Cramer's rule, we are going to set up our augmented matrix as we have been, okay? So I have, again, we're taking all of the coefficients. I've got 1, 1, and 12, which is coming from here. And then the 1, -1, 6 is coming from here. Okay, I don't really think I need to go into that. You guys have had a lot of practice with that already. Now, to solve using Cramer's rule, okay, it's a little bit different for us, but actually an extremely useful method. And like I said, probably this is my favorite way to actually solve systems. So we're going to set up our matrix where we're going to write out the original matrix, which we have on the side, okay? We're going to come up with dx, dy, and d. Meaning, we are going to come up with 2x2 matrices. Okay, so originally, our matrix here is a 2x3. We want to write dx, dy, and d as all 2x2 matrices. So the way that this works with writing dx, dy, and d, d is going to be what's inside here, the regular 2x2. That's going to be representative of our matrix D, which is what we have here. To come up with dx and dy, the way that this works is we replace the x column with whatever was right of the equal sign. So I'll say that again. We replace the x column with whatever was right of the equal sign. Okay? For dy, we're going to replace the y column with whatever is right of that equal sign. Okay, so that's always going to be the case. The reason why we use Cramer's rule is that we're actually going to be finding what x and y are, and this is just another method. Okay, so find the determinant of each of the following. Okay, so first things first, we're going to find the determinant of dx, dy, and d. So the determinant for d is going to be, and let me clean this up, we multiply the main diagonal and subtract it from the opposite diagonal. So we have 1 times negative 1 minus 1 times 1. When we combine like terms, we get negative 2. So the determinant for d is negative 2. Okay, now let's find the determinant for dx. And I'll write that over here. So we multiply the main diagonal. So we have negative 1 times 12, and we're subtracting it with 1 times 6. So I have negative 12 minus 6, which is negative 18. So that's the determinant for x. Determinant for y, again, same method, guys. Multiply along the main diagonal, subtract it from the opposite. So I have 1 times 6 minus 12 times 1, and you get negative 6. Okay, so again, using Cramer's rule, we set up our matrix, augment the matrix, we come up with dx, dy, and regular d. Dx comes about by replacing the x column with what's right of the equal sign. Dy comes about by replacing the y column by what's on the right-hand side of the equal sign. And regular matrix D comes from the regular 2 by 2 of the augmented matrix. Okay, and that's always going to be the case. Now, you're probably wondering, well, what the heck was the point of any of this? So we want to use the determinants from dx, dy, and d to actually solve for x and y. So in order for us to solve for x and y, this is actually a formula that you guys need to know. And it's not that complicated. The variable x is going to come from dividing the determinant of x by the regular determinant of the 2 by 2 matrix. So we found dx to be 18, and we found, actually negative 18, sorry. Okay, we found dx to be negative 18, and we found d to be negative 2. So negative 18 divided by negative 2 is 9, so x equals 9. This is another way of solving matrices. Okay, I have dy over d. So we have negative 6 over negative 2, which is 3. So y equals 3. All right, so this is how we solve matrices using Cramer's rule. All right, the method that I described up here, I'm going to show you guys in another video of how we can solve matrices using this method as well. Okay, so this method here is actually going to be a little bit different from what we're going to be doing today, and I'll introduce that in probably our next lesson. All right, let's keep going. So let's do example 2. Let's solve that using Cramer's rule. So first step, make your augmented matrix. So I've got 2, negative 5, 2, I have 3, negative 7, and 1. Okay, we need to come up with our matrices for dx, dy, and d, and discover their determinants. So dx is going to come from, we replace the x column with what's on the right-hand side of the equal sign. So I have 2, 1, and we keep the negative 5, negative 7. dy is going to come from replacing the y column. So we're going to replace the y column with what is on the right-hand side of the equal sign. So the 2 and 3 stay, and we're replacing the negative 5, negative 7 with 2, 1. And our regular D matrix is just 2, negative 5, 3, and negative 7. All right, so guys, all we got to do is find the determinants for each of these. So to find the determinant for dx, again, we multiply along the main diagonal, and we're subtracting it from the opposite diagonal. So negative 7 times 2 is negative 14 plus 5, we get negative 9. So this is negative 9. So dx is equal to negative 9. We're going to be using that. Okay, let's find the determinant for dy. Again, multiply the diagonals. So I have 2 times 1 minus 3 times 2. 2 minus 6 is negative 4. So dy is equal to negative 4. And now the determinant for regular d is we have 2 times negative 7 minus negative 5 times 3. So negative 7 times 2 minus negative 5 times 3. We have negative 14 plus 15, which is 1. So the determinant is 1 for matrix D. And now, remember that formula I said. In order to find variables x and y, x is equal to dx over d, and y is equal to dy over d. So I'll have negative 9 over 1, so x equals negative 9. And I'll have y is equal to negative 4 over 1, so y is equal to negative 4. Okay, we're going to look at a few more examples similar to this. Again, hopefully we're getting the hang of this. This is making a little bit more sense. All right, so we have Tanisha and Rachel had lunch at the mall. Tanisha ordered 3 slices of pizza. So I've got 3 slices of pizza, which I'll probably use as 3x, plus 2 colas. And we want to know how much that bill ended up coming to, but we don't have that right yet. So let's just keep reading. So this was Tanisha. We have Rachel ordered 2 slices of pizza and 3 colas. Okay, so we have Tanisha's bill was $6 and Rachel's bill was $5.25. We want to know what was the price for 1 slice of pizza and what was the price for 1 cola. And we're going to solve this using Cramer's rule, which is by applying those determinants. So very first thing though, guys, I'm going to be a little nitpicky here. You need your let statements. Just let x equal price for pizza. And we're going to let y equal price for cola. Okay, so we have to come up with our augmented matrix. So I'm going to write that over here. We've got 3, 2, 6, 2, 3, and 5.25. All right, so let's write out. We need the 3 matrices. We need D, we need dx, and we need dy. So D is going to be 3, 2, 2, 3. Remember, we take the regular 2 by 2 matrix. Dx is going to come from replacing the x column with what's on the right-hand side of the equal sign. So I'll have 6, 5.25, and we leave the y column of 2, 3. And then dy is going to equal, we leave the x column, so we leave the x column of 3, 2, and we replace the y column with what's on the right-hand side of the equal sign. Okay. All right, so now we actually need to find the determinants for these matrices. So maybe you want to pause the video here, guys, and see what you come up with for the determinants here. All right, so hopefully you got the same determinants as me. I got d to equal 5, dx to be 7.5, and dy to be 3.75. So now we want to solve for each of these variables. We know x is going to equal dx over d. And we know dx is 7.5, divide that by 5, and you end up getting, just put that in the calc, 1.5. So 1.5 is x, which is the price for a slice of pizza. And we have y is equal to dy over d, which equals 3.75 over 5, which again, when you put that in the calculator, you end up getting 0.75, which is equal to y, which that is now the price for a cola. Okay? All right, let's keep going through. Again, this is just all practice for you guys. All right, so I'm going to take a look at a few more examples here. Guys, questions 7, 8, 9, 10, 11, 12, they're all the same. It's just more practice with this. So I'm going to take a look at question number 11. All right, so again, we got to create our augmented matrix. Now, you should notice here that this is not written in the proper order. We need the x's to line up, the y's, and then we have our equal sign with the answer. That does not match what we got going on here. So let's fix this. We have 27, and I'm going to write out some space. So I'm going to take over on the right-hand side as well here. So we have 27 plus 4y equals 3x. Well, just to do some quick math here, I'm going to subtract over the 27, and I'm going to subtract over the 3x on both sides. So now I have negative 3x plus 4y equals negative 27. That looks a lot better. I have my x's, my y's, equal sign, and then the constant on the other side lined up. Okay, now let's just fix this equation. So I have y equals 1/3 x minus 8. I'm going to subtract over the 1/3 x. So now I have negative 1/3 x plus y equals negative 8. So those are my two equations that I'm going to use. They're set up very nicely for us. Again, we have the x's are lined up, y's, and what's on the right-hand side of the equal sign. All right, I'm going to erase this, and we're going to create our augmented matrix. All right, so this is what my augmented matrix should look like. So again, we're using Cramer's rule. So Cramer's rule, again, that's using dx over d to get x, dy over d to get y. Okay, and you guys will see questions like this in your delta math as well. All right, so let's first figure out what d is equal to. So we have d is going to be a regular 2 by 2 matrix. So I have negative 3, 4, negative 1/3, and 1. Okay, and let's come up with dx. So dx, again, replace the x column with what's on the right-hand side of the equal sign. So we'll have 27, negative 8, 4, and 1. And then dy will solve by replacing the y column by what's on the right-hand side of the equal sign. Okay? All right, and guys, if you want to pause the video here, again, we're just finding determinants. So we're multiplying along the diagonals and subtracting them out. Multiply along the main diagonal and then subtract them out. So pause the video here and let's see if we get the same thing. All right, so these are all the determinants you should have. We should have the determinant for capital D is negative 5/3. The determinant for dx should be 5. And then the determinant for dy is 15. So now, guys, we just got to solve for x and y, remembering that formula. Dx over d is x, dy over d is y. So I'll have dx over d is equal to, I have 5 over negative 5/3. So I'm going to do a little keep, change, flip. And I'll end up with negative 3 for x. Okay, dy, we'll solve for y using dy over d. So we have dy over d. I have 15 over negative 5/3. Again, a little keep, change, flip. This will become a 3. This becomes a 1. So I'll have y to equal negative 9. All right, guys, hopefully, this video was helpful to you. This is all the skills that you guys need from this lesson using Cramer's rule again. If you want some extra practice, you can stay along and watch the rest of this video, and I'm going to continue with question 13. So again, if you understood everything I've gone through so far, you don't need any more practice, you're good to dive into that Delta math homework, go for it. I'm going to go over question 13 for those of you guys that want the extra practice. All right, so we've got on Monday, Maria babysat for 4 hours, and she did yard work for 2 hours. She earned a total of $41. On Friday, she babysat for 5 hours and did yard work for 3 hours and earned a total of $55. We're going to write a system of equations, and we're going to solve using Cramer's rule, which, don't forget, Cramer's rule, dx over d is equal to x, dy over d is equal to y. Okay? All right, so let's take a look. Our first system of equation is going to look like 4x plus 2y equals 41. And our second equation is going to look like 5x plus 3y equals 55. Now, I showed you guys how to solve systems of equations using Gaussian elimination. I don't know if you could sense the reason why I like Cramer's rule so much more is because it's a lot quicker, less steps, and I just think, you know, it just saves you some time. Gaussian elimination, as you guys have seen, is just a lot more steps. Okay, as I spoke to you guys over our Zoom call, I know some of you guys were like, why are there so many steps to this? It's just the nature of Gaussian elimination. Okay, if you like Cramer's rule better, then use Cramer's rule. I think this is a lot quicker to use. You're solving for x and y, saves you more time. Okay, so next piece we want is to come up with the coefficient matrix. So our coefficient is just going to be, we've got 4, 2, 5, 3. Those are the coefficients. Okay. All right, and we want to come up with the determinant. So we've got 4 times 3 minus 5 times 2. We've got 12 minus 10, which is 2. So the determinant here is 2. All right, we're going to use Cramer's rule now to find x and y. So let's write out, I'm going to write the augmented matrix now. The augmented matrix was 4, 5, 2, 3, 41, and 55. All right, so let's come up with dx over d to get x and dy over d to get y. That's the goal. Okay, so let's actually start off with finding dx. So I'm just going to erase this, but remember, keep in mind that's our goal. All right, we already know d. Let's get dx. dx is going to be replace the x column with what's on the right-hand side of the equal sign. So I have 41, 55, 2, and 3. Our determinant will be 41 times 3 minus 55 times 2. 41 times 3 minus 55 times 2 is 13. So dx is equal to 13. All right, let's come up with dy. So dy, we're replacing the y column with what's on the right-hand side of the equal sign. We leave the x column, and we're going to find our determinant here. So we'll have 4 times 55 minus 41 times 5. And when I do that, I end up getting 15. So there's your determinant of y. All right, now we just got to solve for x and y. Remembering dx over d is equal to x. So dx is 13 all over 2, which is 650. So that's x. So she's getting paid $6.50 an hour for babysitting. So that's for babysitting. Okay. And let's calculate y. So y is going to be dy over d, which is 7.5. So she's getting paid $7.50 an hour for yard work. Okay? So it asks in our next question, what was Maria's hourly rate for each activity? Well, we just wrote it. It's $6.50 an hour for babysitting, and it's $7.50 an hour for yard work. Okay? All right, guys, I hope you guys found this video helpful. Get started on your delta math. Again, this was all using Cramer's rule. As always, if you have any questions, you want to FaceTime with me over Zoom, happy to do it. Happy to answer your questions. Like I said, matrices is probably one of my favorite units, and hopefully you guys like it as well, too.